All right, I have tied a string onto the magnesium after it's been coiled, like the instructions stated. I am now going to insert this into the eudiometer, which is filled with acid and water. Since acid is more dense than water, all the hydrochloric acid is down here right now. So I'm going to put the magnesium in at the very top. Insert it goes down about maybe an inch or two down in. I'm going to seal it with a one-hold rubber stopper. The hole allows the gas to escape the eudiometer. Okay, I'm going to cover the hole. I'm going to invert this tube into the water down here. We have water down in the beaker. I'm going to invert the tube, and as the acid travels down to the magnesium, the chemical reaction is going to occur. So here we go. Cover in the hole, put it in the water, stick in the utility clamp, and we're off and running. Let's see if we can get a little close. It's not really, yeah, you can kind of see, it looks like kind of like an oil slick where the acid is dropping down and working its way down to the magnesium. So when that magnesium hits the acid, or the acid hits magnesium, we should get a chemical reaction taking place. Also, while I have the camera here and we're waiting, let's record the temperature. Whoop, I'm going to turn itself off. Let's try that again. All right. Okay. Now you want to make sure you record your temperature, because that's important when we need to plug it into the ideal gas law itself. Okay, I don't know if you can see it or not, but we do have some bubbling going on down at the bottom where the acid has now come in contact with the magnesium. So we're now producing hydrogen. So let's let this reaction take place. So you can see right here, now we're getting quite a bit of hydrogen being produced, which is bubbling, rising to the top. And if we look towards the top, we can see that now this is all hydrogen. So as gas is being produced, it's displaced in the water and it's working its way down. Let's take the reaction taking place. Okay. The reaction has stopped, which means all the magnesium is gone. So now what we have to do is we have to take a close look at the eudiometer. And so now we have to read the volume of hydrogen gas that was produced. So reading the eudiometer, it's like an upside down graduate. At the very top of the eudiometer, when there's no gas, this is 0. As a gas is produced, it'll move down this way, and there's 1, I don't know if you can see it or not, 2, 3, 4, 5, 6. So I'll put paper behind, maybe that'll bring those numbers out for you a little better. So as a gas is produced, the volume's going down this way. So we have to read the eudiometer at the bottom of the meniscus. So that's going to be right down here. Now remember, here's 42, there's 43, here's 44. So I will go ahead and take a still picture of this and post it with this video, and that way you have an easier time of reading the volume. So remember, when reading the eudiometer, it goes up like an upside down graduate, 39, 40, 41, 42, and this particular eudiometer goes all the way up to 50. So I will take a still picture of this and post it with the video so you can make an accurate reading of what volume of hydrogen gas was produced. Here is a blown up picture of the eudiometer after the reaction has stopped. The eudiometer now contains hydrogen gas. So you need to recall that when you are reading a meniscus, you read the bottom of the meniscus. And I would like to remind you that a eudiometer is like an upside down graduate. So I labeled the picture to help you out a little bit here. This is 44, this is 45. So you want to make sure you're reading from here down. So again, remember, a eudiometer is like an inverted graduated cylinder. So you're going to read the volume 44, 44.1, 44.2, working your way down the eudiometer.